As we go into topic 6.1, exponential functions and their graphs, we want to give you some background information that what they'll be doing throughout the practice and certify is giving you 4 graphs and then a function, and you are to, in a sense, multi-choice, pick out the graph that matches the function. So in doing that, we're going to take a look at this first function and kind of give you some general overall hints at picking these out. Now I've put up a few scenarios of kinds of things. This is the one we specifically are asked here. So let's do this. If x is a -1, 3 to the -1 is the reciprocal of 3, which is 1/3. 3 to the 0 power we know is 1. Anything to the 0 power except 0 is 1. 3 to the first is 3, and this is 9. And then we'll graph these to get the general shapes. Now here, this is our base is 1/3. So x to the -1/3 is the reciprocal, where x is a -1 of 1/3. So this would be 3. This to the 0 power is 1. Now here, 1/3 to the first power is 1/3. And this is 1/9. Now here, this might seem a little confusing, but remember, if we wanted to make a negative exponent positive, we just take the reciprocal of this, which is 1/3, and then now our exponents would all be positive. So anytime you see a negative exponent up here, just flip it. That's that rule of the exponents. And of course, it would be this one here. So let's quickly sketch these. This is going to be at a -1, it's 1/3. Then at 0, it's 1. At 1, it's 3. And at 3, it's 9. So again, I'm going to try to sketch this as best I can here. So what features would you look for when you see this? Well, the shape of this, when our base is greater than 1, is going to have this general shape here. That is, it's going to start low, and then as it goes to the right, increases, goes up. Now, for this one, when we have a -1, this is going to be 3. And if we had a -2, that would have been 9. So it's going to look like so. Goes through 1, and then 1/3. So the graph of fractions where our base is greater than 0 but less than 1 will have this general shape, whereas we show the curve starting high on the left and then going down. These are the fractions. So this one, since it's a repeat of this, would again have this general shape, always going through 1 and then getting down here. Now, some other terms of review. We say the x-axis is the horizontal asymptote. The domain of these, all of these right now, is from negative infinity to positive infinity. And the range never reaches 0 on the y-axis, so parentheses 0 comma positive infinity. So again, we're not going to do this one for each one, but it'll give you the background that you should have in your notes as you work on these. All right, let's go on to our next one. Now, with our previous work, looking at this, again, what technique might you use? Well, since this is a negative exponent, to make this positive, we would go f of x equals the reciprocal of this, which is 3 to the x power, and that was the one we just did. So, in sketching it, it's going to be this general shape where it'll go through 1 and 3 and 9, 1/3, 1/9, 1/27, and that should be easy to pick out. Oh, I didn't get to go through the 1 here. All right, well, anyway, you got the idea of what's going on. So hopefully this one's an easy one as we look at it. Example 3, we have this function. Now, notice it's in the form of an improper fraction here. I made it into a decimal form. This is 1.5. So let's study it. Now, there is a protocol for doing these. And step 1 is just forget about this transformation and set the graph up to get its general pattern. So I've done a t-chart over here, and we're asked to put these values in for x. And forget temporarily about the -3 just to get the general shape. So I'll give you a moment. I'll do it. You can do it. Let's see what you get. Now here, this is just to help us pick out the general shape of this. So let's just plot it. So -1, about 2/3 here. And remember, and then we get this 0 is going to be 1. It always goes through 1 when it's 0. Now, when it's 1, it goes through 1.5. So a little higher here. And then 2, 2.25, which is about there. And then 3, a little higher still. So our general shape of the curve, which we already knew, which was greater than 1, but not a 2 yet. Remember, the 2 we said would go more this way. And just reviewing some of the words here, we're going to shift this here shortly. And reflected is when it's on the other side. And we have this axis of symmetry that we spoke of. Stretched, here we see it's not compared to this line. This one would be stretched. If this were our original, this line now would be the compressed as it gets closer to the y-axis. Just some review of the kinds of things that can happen to a graph. So let's clear this up and we'll do our what we call shift. And when we see something like this, where x as our exponent -3 actually goes into the system as a +3. So I've indicated that. And now on this, well, we could use the same graph. Let's show what this would look like. So I've taken each of these points and shifted them to the right. So I saw that this was our original shape of just, let me grab that here. Had to do some adjustments there. So our original shape and now our new shape, it took this and just stretched it out, that is, shifted it to the right. So picking out the graph gives you an idea of what's going on. Now, keep in mind, if you have a graphing calculator, or you can use Desmos, putting this in there, and if you put the original part here, that'll give you the red line. Of course, it's all the same color on your graphing screen. And then do another one where you put a -3 in there, you'll see it shifted it to the right and in a sense extended that this way. Okay. Well, you'll be trying this in your practice and certify. Now, in doing this one, it says solve the following elementary exponential equation. Now, all of these in this section will have values for the exponents that are not decimals. They're going to be like whole numbers, integers. So the key is isolate the variables on one side if you can. And this one is pretty much, we have a variable on this side, variable on that side. Now, the second step is to get your base so the bases are somehow the same. So here our base is going to be 1/4. This is already in its basic form. And now we have to change this 64 so that it gets into the base form of 1/4. And we're going to do some modifications up here. So let's think about that for a moment. See what you come up with. Well, here I had to do some brainstorming and thinking, creative thinking or whatever. And 4 to the third power is 64. But we don't want a 4 here. We want a 1/4. So if I had this as a 4 to the -3, that would become 1/64. So what do I need to put by my x here to get this to be 1/4? But I'd have to put a -3 there. So now my equation reads 1/4 to this power, 1/4 to this power. Remember, we don't know what that x is. That x is the unknown. But we've taken it to the second level where our bases are the same. And now we equate the exponents to each other. So we get 8x plus 13 equals a -3x. So you wanted to see where that -3 came from here. So now we transpose this to the other side and get a +3x. So this is 11x. Transpose this +13 to this side, where it becomes a -13. Divide both sides by 11, and x is equal to a -13/11. 11ths. Wow. So this one was a challenging one. You're going to get others that aren't quite so challenging as this. They started us off with a rather difficult one. As we look at example 5, again, it's picking out from 4 graphs that they're going to give you. And you want a protocol for finding what's that general shape. And then we're going to do some transformation by applying the -3. Okay, let's check this out here. So again, we just want to take a look at this part here. Keeping in mind that when the exponent of our variable is in the denominator like this, it might have looked like this originally. So again, this is over 1. To make this exponent positive, we just take this, bring it down to the numerator, from the numerator, I should say, to the denominator, and it looks like this. Now, what might this look like? Well, this is going to look like 1 over, can you see that 1.75 is almost a 2? So what does 1/2 to the x power look like? Remember, it's going to start high, and it's going to go like so. So this is going to be the general shape of the graph that you're going to pick. Now, what we're going to do with that is shift it now. Now notice the -3 is not in the exponent position. This is sort of in its y-intercept position. So what are we going to do to the general shape of this graph? Well, we're going to drop it down from where it was, and this would be like the 0 point here, 3 units down. Okay. That's what this -3 will do to this overall shape of the graph. And remember, anything to the 0 power goes through 1, which would have been here, so it would be right there. So our graph is going to look something like this here. So what I did, by the way, just to show you what's going on here, is actually pick the correct answer, and this is what the correct answer is looking like. Now again, if you have the graphing calculator or Desmos, and you put this original function into the graphing calculator, it'll show you this. But notice where that line would have gone through here originally, we're shifting it down. This is when it's the y-intercept, 3 places. So 1, 2, 3 from that point, but from the 0, it's down 3 as well. Okay, again, this was a rather challenging one, but taking it in pieces, getting your general shape, hopefully is helpful. All right, let's go on. Now, going on to number 6 and analyzing it a little, I've rewritten the 3 minus x as a -x plus 3. So in a sense, with that -x exponent, I knew that this fraction is possibly going to become a 5, and I'm not sure that these are equivalent, but I do get the idea that it's going to be sort of like this in my final selection. So what I've done here is I've gone to Desmos, and just to show you how this can possibly help here, I'll switch screens and going to do some modification. And again, some of these are challenging, and having the ability to go to Desmos to put the work in. So our red curve is, this is 1/5 that I converted to a decimal. And we see the red line, and the one that would be the one that you selected looks like so. So it is in the upper quadrant, that in the first quadrant, that it goes up, and it's not starting high and going down as you might think because of being a fraction, because of that negative exponent here. Now, I flipped that up and made that a 5, but then I made that exponent positive, and then I made that, again, it's a little, I'm not too sure is what's going on. So we'll stick with this one as being our solution, and noting that these are not equivalent. And I think it might have to do with the parentheses or the negative values. So sometimes the use of a calculator is going to be very useful in picking out the correct answer. Okay, going on to number 7 as we see it. Let's write it up here. 32 to the x power. And our protocol is to isolate the variables on one side if you can. So I'm going to bring this over to the other side as a positive 2. Now this is 2 to the first power. We want to get 32 to be some value as a base of 2 to some power. We know this is going to be 2 to the first. Let's see what we can do in some brainstorming here. Did you get something like this? So 2 to the 5th is 32, and then we have our x. So rewriting this, this is going to be 2 to the 5x power equals 2 to the first. So now our bases are the same. And you might say, what is x going to be? Well, we're just going to divide both sides by 5. X is 1/5. Because if we go 32 to the 1/5 power, that would be the 5th root of 32, converting it to its radical form, which is 2. Okay. Now, in example 8, we have our original example, 2 to the 5x minus 8th power is equal to 1/4. So we want to get this 1/4 here to become some power of 2. Now, we know that 1/4 is equal to 2 to the negative 2 power. So if I put up here 2 to the negative 2, this is 1/4. But now our bases are the same. So what do? Well, bases are the same. You set up your equations. I'm going to bring this -8 over to this side as a +8. So this becomes a 6. And now 5x equals 6. So x is going to equal 6/5. And if you take 6/5 of this, this becomes a 6. 6 minus 8 is -2. 2 to the -2 power is 1/4, so it checks out. All right, one more to go. In our last example, example 9, we're going to use a similar protocol. So 10,000 to the -x equals 10 to the 3x minus 5. Well, our base here is going to be 10. Now, 10 to what power is 10,000? Well, that's 10 to the 4th minus x out here equals 10 to the 3x minus 5. So this then becomes 10 to the -4x equals 10 to the 3x minus 5. And we have our basic equation here. I'll bring this over to this side as a -3x, so this becomes -7x equals a -5. X will be a +5/7. Now if you put this 5/7 where the x is and check it out, it does check out. I did it on my calculator, and this is the answer. Okay, well, again, you're going to have your own challenges as you do the practice and later the certify, and hopefully this is helpful.